you want something that's kind of cool? I have two objects that both have the same mass, but this object has most of its mass in the middle, the red one, and the blue object has most of its mass around the outside. So, the question is, when I release them, which is going to hit the bottom of the ramp first? Red, mass inside, blue, mass outside. Go ahead and take a vote. And look at that. The red one hit first. Now, all objects free fall, meaning falling this way, at the same rate, no matter their mass, in a gravitational field. But it turns out that when things roll downhill, it gets a little more complicated. What matters is where the mass is placed, what the shape of the object is. So if I have a hoop, which is most of its mass outside, looks like a cylinder, and another hoop, which is really small, different masses, different sizes, they're both hoops. Let's take a guess. What's going to hit first? Look at that. Same exact time for both. So it turns out that two objects of the same shape roll down the hill at the same rate, regardless of their mass, regardless of their length, regardless of their size. We can also see this with cylinders. Here I have a long, skinny cylinder. Here I have a really small, little tiny cylinder. Still counts as a cylinder, by the way. Some people might call it a disc. A disc is a cylinder. So now I'm going to go ahead and have a race. Here we go. 3, 2, 1. And you can see, again, they got down at the same exact rate. Now, I'll take the hoop just to show, and the cylinder. And the cylinder beats the hoop easily. It turns out that the further mass is away from the center, the harder it is to rotate it. That's called moment of inertia. So this has more moment of inertia. It's more difficult to rotate this than this. All of its mass is more near the center. It's easier to rotate. So hoops are going to go down a hill slower than discs. Physics is pretty fun.